Hello, Happy New Year. These notes go on page 95. Your content objective is we will use graphs to solve systems of linear equations. Your heading is systems of equations, and then we're going to get right into it. Systems of linear equations. What are systems of linear equations? Well, a system of linear equations is where we solve multiple equations at the same time. So example 1. Example 1, solve this system by graphing. So what we already have over here is we already have the graph done for us. I just wanted us to make sure that we knew what the lines looked like. But let's get back into the habit of looking at our equations and trying to figure out what our m and what our b are for those equations. So m is our slope. That's a horrible S. Let me erase that and start over. Our m is our slope. And the b is our y-intercept. So if we look at this first equation, y equals 3x minus 2, we see that that's our blue line over here, and our slope is 3, and our y-intercept is negative 2. And then for our next one, we have to consider y equals negative x minus 6. That's the green line. Our slope is going to be whatever's right in front of x. In this case, it's a negative 1. And our y-intercept is negative 6. So the solution to a system of equations is found where the two lines intersect. Where the two lines intersect. So in this problem, our solution is right here at negative 1, negative 5. And all we had to do was graph those two lines to be able to see where that solution was. There are three possible types of solutions when finding solutions of linear equations with two variables. So for case 1, we have two lines that cross each other, so the number of solutions will be one solution, and that is found where they cross. So wherever they cross, that's where your solution is. For case 2, if we have two lines that are parallel, we know that means they have the same slope. So if two lines are parallel, you will have 0 solutions. So no solutions at all. It makes sense because the lines don't cross each other. And then for case 3, we only have one line drawn there, but really what I want you to think is that there is a second line that's drawn right on top of the first line. So if that's the case, if you have two lines that are graphed right on top of each other, they have infinite solutions. That means there is no limit to the number of solutions for that system of linear equations. Okay, so now we have example 2. Example 2 says, which of the following graphs best represents a system of equations that has no solution? This same problem can be found on the released STAR test, the released Algebra 1 STAR test from last year. So we know we're looking for something that has no solution. And if it has no solution, that means we're looking for two lines that never cross. And if we know that they're never going to cross, that means you should be thinking that these two lines have to be parallel. So automatically, we know that we can cross off B. The reason why we can cross off B is because B has a solution right there. Let's look at A. A is decreasing, but if we continue the line this way, we continue this line this way, we see that eventually those two lines are going to cross each other, so we know it's not A. We know it's not going to be C for the same reasons, because the slopes are not the same. And then with D, we have two lines that both have the same negative slope. They both go down 2 and over 5. Down 2 over 5. So that means that D is our answer. Since they have the same slope, they're never going to cross each other. That means that there is no solution. Example 3. How many solutions will the following system of linear equations have? So we have y equals negative 1/2 x plus 6, and we have y equals 2x plus 1. So, what we should do first is we should try to figure out what our slopes are for these two equations. So y equals negative 1/2 x plus 6 has a slope of negative 1/2, and it has a y-intercept of 6. And then for our second one, we see that it has a slope of 2 and a y-intercept of 1. So now, the next question that we need to consider if we want to figure out how many solutions these are going to have is, are the slopes the same? So look at your two slopes. Are those the same? No, they're not. And the next part we need to see, are these two lines parallel? Well, if they're going to be parallel, that means they would have the same slope. So since they don't have the same slope, are these two lines parallel? No. So are they the same line? No. They would have to have the same slope and the same y-intercept, and we see that they do not have the same y-intercept. So if they're not the same line and if they're not parallel, how many solutions will a system have? Only one solution. So what is that solution? Okay, another way to find the solution would be to take our two equations and set them equal to each other. So if we take equation 1, which was y equals negative 1/2 x plus 6, we'll say negative 1/2 x plus 6. We're going to set that equal to our second equation, which was 2x plus 1. Because we know that both of these are equal to y, so what we need to consider is that y is the same for both of them. That's why we can put the equal sign in between. And then what we need to do is solve for our variable. So if we remember, we have dumpsters contain very nasty stuff. So the D was distribute. Is there anything we need to distribute here? No. Dumpsters contain not just nasty stuff, but very nasty stuff. Okay, so we know we don't have anything to distribute, so we're going to cross off that. Combine like terms. Nothing to combine like terms on either side. So variables on left. Let's move the variables to the left. In order to do that, I need to subtract 2x from both sides. So if we're already at negative 1/2 x plus 6, and we take away another 2x, we're now going to be at negative 2.5 x plus 6, and all that's going to be left is 1. So after we move our variables to the left, we have to move our numbers to the right. So I'm going to subtract 6, and I find out that I have negative 5. So negative 2.5x equals negative 5. If we divide, that's our simplify right here. If we divide both sides by negative 2.5, divide by negative 2.5, we find out that x equals 2. And then I go back up and I plug that 2 in for x into one of my equations. So y equals 2, parentheses 2, plus 1. It's 2 times 2, 4. 4 plus 1 is 5. So my solution is going to be 2, 5. Okay, that's all for today. We're going to have a quiz Wednesday, January 8th. It's going to be over that table that tells you the number of solutions. and also graphing the systems, not necessarily what we just went over with solving by setting them equal to each other. All right, I will see you tomorrow in class. Thank you.